Number 27, remove element. Given an integer array nums and an integer val, remove all occurrences of val in nums in place. The order of the elements may be changed. Then return the number of elements in nums which are not equal to val. Consider the number of elements in nums which are not equal to val be k. To get accepted, you need to do the following things. Change the array nums such that the first k elements of nums contain the elements which are not equal to val. The remaining elements of nums are not important, as well as the size of nums. Return k. My first response is that this reminds me of one of the problems to say kind of close to the last one actually, where they don't care about the remaining elements and also it was in place. So I feel like, even though it's been a couple days, think that they share quite a number of similarities. Well, before we get into the examples, do I have any questions? So the way we did it for the last problem was that there was no way to delete values in an index, nor setting them to void was not an option. All we cared about was that for however many number of the duplicates, we replaced that many elements in that array. Versus here, do I have any questions? I'm guessing the value is only 1 since it just says int val. Important aspect of the last problem was that it was sorted. This one doesn't say it's sorted. I don't think I know how to take advantage of sorted just yet, but I think it is a question to ask. Let's try to get into the examples. Input the array 3223 and the val that we're trying to remove is 2. We're changing the array itself. How many elements were there in the array that were not equal to val? So in this case, val, which is the one that you're trying to remove, is 3. So of the 4, how many were not 3? And the answer is 2. So we output 2. So approach. My approach, I'm gonna try to use what we learned from last problem and have a counter. So in place means that we are not making another array, keeping the space complexity the same. I don't think it is necessarily saying anything about time complexity. Obviously we want to do it in, feel like I want to say O(n). So the approach here, what we're going to do is we loop through the integer array nums and count. So we're going to go brute force way first. There's gotta be a more clever way to do this with just one loop, but for sake of time, which is ironic, I'm gonna try to code what comes to my mind first. First, I'm gonna loop through to see how many val exist within this. So the first loop is there. Actually, I feel like I know how to do this in one go. And I think it's going to involve, while what we're saying is that we loop through the nums array, and if we happen to find a val at the index, we're going to increment the k. I feel like I have to do some sort of incrementation for I so that we go until it is not. Also, if it is the very last index of the array, then this plus is not going to work. I think there is a simpler logic I can check. Something is off, I just can't verbalize it. I know this is wrong. O(n) squared isn't going to cut it. But time limit exceeded maybe also means that there's an infinite loop, which I think may have happened here. Have the right instinct, but there are a few significant issues. Okay, there is an infinite loop. Loop never increments I, so it spins forever on the same index. I sort of knew it, so when it is the last one, it doesn't protect against this. I feel like I always mess this up somehow. Early break. The else break means you stop the entire scan the moment you hit a non-val. K is counting wrong. K should be the count of elements kept. I'm just curious if this would even be accepted. Okay, yeah. Still taking too long. Reviewing the solution that actually works. We start with initialize it to 0, a simple loop. Where do we go awry? So instead of saying if the num of I is val, they say if it's not val, then we say k. So this happened before too, and feels dumb to kind of face a similar answer. I feel like I'm not getting it right now. K is a slow pointer number of elements that are not equal to val. So if we were to use this and then apply, so we start with 3 and val is 3, so they are equal. Therefore, K does not change. So they're equal, so we don't do anything. And then we go to 2. It's not val. K is still 0. The 0th index, which currently holds 3, is going to be the current value, which is 2. And then we increment the k, and then we return the k at the end. There is one pointer that is pointing to I, which is scanning every element. K is a slow pointer where the next kept element goes. Today we visited the remove element problem from LeetCode, which even just from the title was very apparent that it was going to be very similar to the last problem we did, which was removing duplicates. So it seems that whenever we are removing items from arrays, utilization of two-pointer methods seem to be an ideal approach. Quite frankly, I want to believe that if I were to have done this the day after or the day of having done the last one, I feel like I would have most likely have gotten it. Definitely taking a couple days of break weakens the links when it comes to this, sprouting programming skills. So that was a little rough, knowing that I should be able to solve this and it's almost there, but I can't quite put my finger onto it. Another interesting note for today was the question I had: if the array was sorted, would that have changed anything? I think when we compare it to the solution that involves, call it, two-pointer method, don't think it would change it, but there may be alternative ways to solve it because, all the values that we're trying to exclude would clump up, and that might allow you to take them out more conveniently, logic-wise. But in terms of overall performance, shouldn't really change. I was actually trying to make a video that talked about two-pointers because I noticed that even from this very limited question pool that we have here, I want to say at least a third of them already has been using a two-pointer. And I was watching quite a number of LeetCode videos, and in particular, when it comes to LeetCode, I think it's inevitable that you come across the YouTube channel called LeetCode. This guy, very helpful in explaining how, we can't get good at something unless we put in time, and that was a little bit reassuring. I know it's gonna take time and reps, just like learning a musical instrument. If I haven't put in, 10,000 hours, but expecting myself to perform the same level is almost insolent. So I'm gonna keep adding reps and just reviewing my notes and revisit some of the old problems and just continue to grow working on my projects and class material. As always, thanks for watching. Any feedback you guys have would be greatly appreciated, and hope you guys are enjoying the Memorial Day weekend. Bye.